Okay, e to the negative
0.22x.
22x. And equal to 20. Okay. Which, by the way, you notice the similarity there? Okay. So in this case, I think they wanted you to find what x would be for this to equal that, right? So when I come back to it here, I'll explain what this equation is about. So right now, we just want to try to get through the algebra to find the x, right? What did some of you guys try?
I think on Pearson, like the question help said to graph it on your graphing calculator.
Oh, and solve it just by graphing? Okay.
I solved it algebraically.
Okay.
Yeah, I tried to do it on my graphing calculator. It didn't look anything like.
Okay. So let me show you how to do this one algebraically, because then we'll kind of consider that to be 2 times through the process we're going to do up there. Okay. So it's redundant, but I think that would be beneficial. So I mean, let me just give you a simpler problem for a moment. If I had 5 equals 2 over x, what would you do here? Yeah, multiply by x over 1, multiply by x over 1, right? You can see now that would reduce, and you'd end up with 5 equals 2x. And of course, you're there. You can solve that, right? Different problem altogether. Okay? But I thought if you could see that, then you'll be able to see this. Okay? So we're okay with how you deal with something in the denominator, right? Sometimes you also might want to go into a cross-multiplying approach. All right, so coming back to here then, so that's what we're going to do, really the same thing. So this is 1 plus 47.5 e to the negative 0.22x over 1. So then what we're saying is that's going to go away. And of course over here I'll multiply by the same thing. 7.5 e to the negative 0.22x, like that, okay? Multiply both sides by the same. So now all we have over here is 50 equals 20, and that whole mess, we'll stick it in there, right? And you could distribute, but it'll probably be easier right now. Let's just get rid of the 20, okay? How did you do that? Yeah, just going to divide the whole side by 20. Okay, so we have 2.5 equals 1 plus 47 e to the negative 0.22x. Now what?
Subtract 1.
Yep, subtract the 1. So now we have 1.5 is equal to 47 e to the negative
47.5.
Oh, thank you very much. 0.5. The camera probably won't pick that detail up. Okay, and now what? Yes. Yep. Divide by 47.5. If you could help me out here a little bit. What do we end up with on the left side there? Is that some funny little decimal number?
0.03157.
Is that what you said, Amy?
Mm-hmm.
Okay, thank you. So that's on the left side, and on the right side now we're just left with e raised to the power of negative 0.22x. Okay? Now what do we do?
Take the natural log.
Good deal, yep. Natural log of both sides. So now I have negative 0.22x, and of course natural log of e is just 1, so we'll leave that away. Just leave it out. And now I have the natural log of that funny little decimal number.
Negative 3.4556.
Okay, I'll stop there. But in your calculators, it doesn't hurt to keep those numbers. And now, of course, the last step is we'll divide by the negative 0.22. Okay, and what's our x equal to?
15.7057.
57 or 057?
7057.
Okay, so we could do some rounding on that. That's kind of the process. And I hope you can look at this not as that you're memorizing the steps we go through. Because really PEMDAS should get us there. Okay? But again, when it's a little uglier, sometimes, PEMDAS gets blurred in there. But the steps are PEMDAS. It's basic algebra just with some uglier stuff. Okay? So there's really no special tricks in there. Okay. So can I go ahead and erase this? Okay. So you recognize this is really the same as what we had just a moment ago, right? It's called logistics. And so let's do a real full-blown problem with this. In a little bit, actually, I'll have you graph one of these in your calculator. But if you were to graph it, this is what you get. Now, of course, exponentials would go like that, right? And this starts out as an exponential. It's growing like crazy. Can you imagine you buy, 6 fish, toss them in your pond? I did this. I bought a couple goldfish from Walmart. Next time I looked in there, it's like I had hundreds of goldfish. So they're growing like crazy, but guess what happens next? But why is that? What is that?
Your environment's getting too crowded.
Might be getting too crowded, might be not enough food. I mean, I was trying to give them some munchies and stuff, but yeah, so you're right. That doesn't keep on going forever. You'd have an entire pond with just fish, right? Or we did this. Actually, you guys took 94, right?
Yeah.
There was one where they did this with 94 about bacteria growing at a certain rate. How long did it take to cover the earth? Do you remember that one? You didn't sink in very well? No. It really wasn't that long to have 6 feet of bacteria around the earth. It's kind of gross. But anyhow, so what happens though with the logistics is you get here and you start running out of food and space and it goes like flat. Okay? And this is what we consider something you can maintain. All right? So that's what the logistics curve or the logistics equation is about. And actually, it's a very common thing. It happens all the time. Okay? So, just like we were doing the exponentials on Monday, so now we're going to do the logistics. Start off with our 6 bacteria, and find B if there are. So, after a long time, we have 1,806 bacteria. I just came up with numbers that kind of worked out a little nicer. In case you're curious, I wasn't counting them all. And also the information we need to know is that we have 400 bacteria after the 5 minutes. So let me write the equation out here. We have y equals, let's see, did I use an A or B on top? I think it was an A, right? Yep, A. A1 plus B e to the negative kt. So that's the equation from the previous page. So let me tell you which parts. And there's nothing sacred about A and B. If you start looking around in different textbooks, you'll find A and B will be different letters. You might find a different letter for the K as well. Okay? So this is just, it's the format. It's nothing special with the letters. A is this max, it's the max value that you can maintain. So in this case, it's going to be our 1800. And a lot of times they'll use words like after a long time. And we're trying to say that's after things have, calmed down, okay? So a long time just means you're past the curve and you're out here somewhere. Right? So with that in mind, now we're going to grab the first situation here. We start with 6. So we're going to do the process like Monday, but we have to actually do it twice, okay? So first we have 6 bacteria at time equals 0, right? Let's plug that in. So I have, where's the 6 go? Yeah, that's right. We have 6 bacteria. Our max we know is going to be this 1806, so you can just plug that right in, right up front, okay? 1 plus, and B we don't know, e to the negative k, we don't know that either, but we know t is 0, okay? So you could think about that as being 6, nope, 0, comma 6 is what we're plugging in to this equation here, okay? And this is the y and this is the t. It's kind of like an ordered pair x and y, but now it's t and y. So, okay, so we have two things we don't know right now, right? But the good news is since that's a 0, 0 times k is 0, e to the 0 is 1, right? E to the 0 is 1. So I can rewrite this as 1806, 1 plus b, like that. Okay? And again, this part in here really is e to the 0, which is equal to 1. That's why we can do that. Now, thinking about what we did over here a minute ago, what will we do now?
Multiply it by
Yeah, we're going to multiply this by 1 plus b. So then this will cancel out, and we'll do the same over here. 1 plus b. Okay? So let's write that out. So on the right side, I just have 1806. On the left side, you could divide through by the 6, or you can distribute. Do you have a preference? Want to distribute? Okay. It's kind of 1 half dozen, 6 of one, half dozen the other. Whatever you prefer. Okay, so we'll just distribute this one, but you could have divided by 6 as well. Okay. So now we have 6 plus 6b. b equals that. So combining like terms, I'll subtract the 6. So now I have 6 equals 6b equals 1800. Okay, then of course divide by the 6. And how many times does 6 go in? Oh, that should be nice. It's 30, isn't it? 300, thank you. Good so far? So now let's come back over here. We're going to rewrite this equation. So I have still my 1800 and 6. I have 1 plus, but now I know my b. E to the negative k. And I'm going to leave it blank for my t. And for right now, I'm going to leave this part blank. Okay? We already know if we were to plug in 0 and 6 again, it would just be true. Okay? So notice down here, though, we waited around a little while, and after 5 minutes, we had 400 bacteria. Okay? So they're growing pretty good. So we're going to plug this next group in at 5 minutes, comma 400. So I'll put my 5 right here, and my 400 right there. So now we're going to repeat the same process we just did. We're going to repeat it, but guess what we're going to find this time? We're going to find the k, right? Which is what we were doing again on Monday, right? Okay, so to get rid of this whole mess here, again, we're just going to multiply by this whole mess, 1 plus 300 e to the negative 5k over 1. And then over here, I don't have quite enough room to do that. So I'm going to multiply this by 1 plus 300 e to the negative 5k. All right, that. So again, this goes away. Just left with that. So again, do you want to divide through by the 400, or do you want to distribute the 400? Do you want to divide this time? Okay. Just to be fair, so we'll actually let me finish writing this part out. 1 plus 300 e to the negative 5k. So yeah, let's divide by the 400 then. So that will go away. And what's that come up to be? 515? Okay, thank you. And on the left side, then we have 1 plus 300 e to the negative 5k. Good so far? And then, of course, we'll subtract the 1. Still working? Seems to be. Okay, and now what? Sure, divide by the 300. So that goes away. So let me rewrite it up here. So on the left side I have e to the negative 5k equals, and what's that come up to be? 117. Okay, thank you. And now what? Yep, natural log of both sides. Good. Natural log, natural log. And of course that's going to allow us then to bring our exponent in front. And so again, this will just feel just like the exponent stuff we did on Monday. So this is negative 5k, natural log of 1 equals, and what's the natural log of this guy?
4.448.
Okay, thank you. And then we're almost here. Divide by our negative 5. And k equals 0.8896. Okay. So here's what we've done. We had two conditions. We knew how many bacteria we started with. Then we knew how many bacteria after 5 minutes. So we took the two conditions. The first condition here and the second condition here. We had to do it in that order. Okay? And we were able to find the k. So now we can actually write out the whole equation. So the equation for modeling that situation, we're going to have 1806 divided by 1 plus 300 e to the negative 0.88. Which rounding should we do? I guess we can go with 4 times t. Okay? So what we believe will happen is we should be able to graph this, and we should be able to get this shape right here. Okay? In fact, you should be able to go back and look and say, okay, right here at 5 minutes. Oops. At 5 minutes, we should be able to see that we have 400 bacteria, right? And then we should be able to go out here for a long ways, and we should be able to see it's flat at 1806, right? So that's what we think we've done. So grab your calculators. Does everyone have a calculator with you today? No. Bummer, Amy. I actually had it in my hand, and then as I grabbed that thing, I set the calculator down. I thought I'd bring it just in case. So let's go open your calculator, though. Click on our y equals. Nope. I don't know why it always does that for me. Okay. There we go. So let's try to type this guy in. So we have 18.6. So hopefully I've got that typed in there right. Oh, need one more parenthesis actually, don't I? There we go. And let's think about the window size. So click on the window button. So here's 0. And we know that at 5 minutes we were here. So how far out do you want to go in the time direction, x direction? Make a guess. 15 minutes? Okay, let's try 15. hopefully in 15 minutes then we'd be flattened out. So we'll find out, okay? So we'll go from...
Know which one's which? How do you know which one's which?
The X's and the Y's, you mean?
Yeah.
It's,
I was to change them in here. Never mind. All I tell you.
okay. So, I mean, here's the X. It says X window. So these are the X values, which X and T are the same thing here. Okay. So we're going to go from 0 to 15. And we're going to go from 0 bacteria to, and certainly we need to be more than 1,800 bacteria, right? So let's give it just a little bit of room, maybe 1,900 bacteria. And we'll click on our graph button and see what we get. I think we made it, yeah. In fact, let's click on your trace button. And so you can see as we move along here, we should be able to go down to, so we're at 6 minutes. So there's roughly our 5 minutes, right? And you can see right between there would be the 400. So that part agrees with the model, right?
Can you go back to your window, please?
Yep, I will in a second here. So we'll go over here. Let's kind of see what it does when it flattens out. So, yeah, wow, we're just barely getting there. So it was like at 15 minutes when we would have got flat. So good guess on that. Yeah. Okay, here's that's not what I had. I wanted 0 to, oh, I know. It changed when I was doing a trace. It actually started to change my window because I was trying to go too far. That's why. So I typed in 15, but 20 would be better. And then again, we go from 0 to 1,900. So. Okay. So how was that? Kind of follow through the process? So when you look at So if you look at this side of the sheet here, so I've given you one full example right there you can look at. So problems then 13, 14, 15. That's funny, I thought I had deleted one of those guys for you. So I'd like you to try to do that a few times there, okay? And want me to just bring the answers on Friday, or you want me to send them to you tonight so you can be checking how you're doing? Or you can just toss me your calculator and you'll know, right? So that's what the last few of these are down here. Just like you to just go through the same steps here. Okay? On the first page, this is really stuff we've already been doing. So like when you compare number 1 and number 2, notice it's the same problem. It's really what it did on Monday. The goal is to find an equation that looks like, well, you can see above here I've listed like 4 or 5 types of equations right in here. So you kind of need to match up which equation would go with which problem. Okay. So, but the first one is a periodic model. So it's going to, I'll just tell you right now, it's going to be this one here. B to the T divided by N. And then right below it is the continuous model. What would that one look like? Y equals? Yeah. To the what? KT. Yep. And again, we use that a few times on Monday. So again, you'll start with the values that are given. You'll plug them in, and you'll solve for the K. So most of these, all I want is what does the equation look like? Okay. And in fact, with the periodic models, most of the time you can write it down. There's no work. Just by reading the problem, you should be able to plug in the numbers for the B and the N and the Y sub 0. Okay. This one here, anytime you do the continuous model, you'll need to plug everything in and then solve for your K, right? And then you'd plug your k in, and there's your equation, all right?
For our test on Monday, do you want us to memorize all the equations?
No, let's do this. On Friday, let's talk about, Friday's going to be review. Oh, yeah, of course. But in general, let's talk through what equations I'll just provide for you and which ones you need to have, okay? So that'll be part of what we can do during the review. And sometime we'll email that or something so you know what to expect.
Okay.
Okay? And let's see. If you look at the second one in the list here, what's the key way you'll recognize if you should be using that equation there? So it's the one that says 1 plus or minus k over n. That's right. Anytime you see a word percentage mentioned in a problem, that's how you'll pick that one out. That's right. Anytime you see something about it doubling or tripling, then you'll be picking out this form here. Okay? I mean, this is what we call our growth factor, but the other option is to have it be 1 plus or minus k over n. So these are interchangeable depending on the problem. Okay? So this is where you would plug your percentage in if it's a percentage, and this is where you'll just plug it in if we just say doubles. Okay? So do you feel like you could kind of start on this okay? Right? On this side here, this is a bit optional, but let me find out. All I want you to do is graph these. If you feel like you know how to plug them in your calculator, I don't know if there's anything to really do with it. I just want you to plug it in, see what the graph looks like. Do you want to do any of those? Are you okay? Certainly they're easier than what we just did, but okay. Then on the back side here, let's do one of these together, and then you can do the other one on your own, okay? So again, this will be calculator stuff. So let me try to walk through the steps. So let's see, if we look at the lower list here, let's do that one since it's a little harder to read, okay? So first, click on your Stat button. It should bring you to this menu right here. There, and just hit either the 1 or the enter. So we're doing edit, right? So we're going to put our data here in list 1 and list 2. You could use list 3 and 4 if you want, but it'd be easier just to use list 1 and 2. Okay. So you can see now in this grayed out area here, we need to enter in 0 through. We don't even have to go clear down to 28. And in fact, you could even get by with skipping a few if you want, okay? So let me enter in the x values first, or the time values. And now when we do these, so this is going to be the catches. Notice the scientific notation there? So we'll need to actually go 1.2, and I'm going to go E, and then put a 4 in. Yeah, 4, 4. Is that okay with the scientific notation button there? So enter. So again, I just need to go right on down the list. And again, if you skip an ordered pair, it's no big deal. He'll do a good job without it. But just don't mix up the numbers. You know what I mean? That'll mess it up. Almost got it here. So as long as you at least have the same number of numbers in the column, we have a chance, all right? And again, if you don't have all the numbers in, don't worry now. Can I start to go through the next couple steps? Okay, so there's our data. So let's go second quit. And then we'll go back to hit the stat button. This time, though, we're going to go out here and do over to calculate. Again, we did edit the first time, right? So calculate, and
What did you guys do?
yeah, actually here, let me just quit back out of that. So you hit stat. The first time we did edit. That's where we did our data, right? If you want to go back, you can do that. So now we go to calc, and you come on down here. So now if we were trying to do the logistics regression, if we thought it was going to fit that, we do the logistics regression. If we think it's going to be purely an exponential like that, we would do exponential regression, okay? So let's actually try both. So let's try to do exponential regression first. So I just put the cursor on it. You can either hit 0.
None of my stuff looks like that.
You don't have that menu, same menu?
I had a whole bunch before that. So what are we doing?
Yeah, which should be between the calculators, it changes a little bit. If you have the 84, you might have, I don't know if it's a longer or shorter list. Hannah, you have the 84. Is 10 exponential regression? Okay, so they kept that number to the same. So you hit enter. Now, first thing we need to do is tell it where the data is at. So it's going to do exponential regression, but we need to tell where we typed in stuff, right? So you go second 1, there's list 1, right? That's where the x values are. And then we need a comma, which is right there. And then we need to find the y values. So again, we go second. You see right there is L2. So I click on L2. Now, just to let you know, the calculator will assume list 1 and 2 if you don't tell it. So you could actually skip that step. But if you ever used, if you chose list 2 and 3 or 3 and 4, you have to enter those in, okay? Now, at this point, it's actually going to give us the answer. So let me just do that. But then I want to take you back and show you one more thing here. So I hit enter. And so what it's telling us is, and notice here, they don't use the y sub 0, they use a. And that's, we have lots of variations out there. So they think the equation that would work would be y equals 86173. 713, thank you.
There's not a 1 before.
Oh, that's where I was, thank you.
Yeah.
Okay. And then the b is 1.6 times 1.6 raised to the power of x, like that. Okay. So the calculator thinks that should be a good equation. Okay. So let's quit. I want to show you this twice here. Okay, I'll clear. There we go. Let's run through the same steps again. Stat, calculate, and again we're going to run down here to option 0, exponential regression. Hit enter. And of course we could do list 1 and 2 again like we did before, right? But here's what I want to show you. I would like to be able to graph this. Of course we could go to the Y1 and type this all in, right? But there's a cool thing where we can actually get the answer put directly into the graphing spot. Okay? It saves you the copy time. Here's what you do. If you don't remember this, again, you just have to do it manually. See the variables key right here? Click on the variables key. Okay. You notice it says Y variables here, right? So you go, there's Y variables. And it says function. Hit enter. And let's put our stuff into the Y1. So enter one more time. And now I'm going to hit enter. There, it's going to do that step again, right? Just like before. But if you go over here to Y equals, now you see it plugged all that information right in there to be graphed. Okay? So I'd like to go through the same steps again, but this time I want to do the logistics model. Okay? So you can maybe just run ahead of me if you want, but I'll just try to kind of go through it. So again, we're going to go stat, calculate. I'll go down the list. And there's logistics. So enter. And again, you could do the list 1 and 2 thing if you want, but we could get by without. And again, I want to store that, right? So again, I hit the variables key, Y variables, function, and this time I want to put it in Y2. So otherwise I would write directly over top of what I did before. So I'll hit enter. And it's going to think about it for a bit. Shouldn't think about it that long though. There it goes. I'm guessing it would be your first time going through these steps.
Yeah, I messed up earlier, so I was still catching up on the first thing you did on the calculator, so I don't even know what you're doing now.
Okay. Well, it's dying. Anybody else get it to work? Okay. Oh, there we go. There, I got to overflow finally. Okay. So maybe you won't like that one enough. So, but let's actually come back to here. Let's try to graph this. Now, that's kind of where we'll stop, okay? So, sometimes you can do the auto zoom thing and it works pretty good, but we should be able to think about this. So we're starting out at a pretty big value, right? Yeah, maybe this would be a good one for zoom. So click on zoom and zoom to fit is option number 0. Okay. Okay. So there's the graph of that exponential. Okay. I think you'll find the data above here in this first table to be a little friendlier. Okay. So I don't really think we have time for quiz questions, so I guess we'll stop right there. Okay. All right. Any last minute questions? Okay. See you on Friday.